Hi to all. Myself Purnima. I am assistant professor in JCT Engineering College. Today we discuss about the subject control system. Course objective to introduce the components and their representation of control system. To learn various method of analysis, time response, frequency response, stability of the system, state variables analysis. In Unit 1, system components and their representation. In Unit 1 comes under control system, terminology and basic structure, feed-forward and feedback control theory, electrical and mechanical transfer function models, block diagram models, signal flow graphic models, DC and AC servo meter, synchronous multivariable control system. Control system. First of all, what's the mean by system? A group of components are connected in a sequence to perform a specific function. The group thus formed is called a system. Next, what's the mean by control system? The system which consists of components to connected together to perform a specific operation or function in which output is controlled by the input. For example, lamp. If lamp is switched on and off using a switch, the entire system can be called as a control system. We have to give a reference input and plant. Plant is the lamp and controlled output. Classification of control system. Natural control system. For example, it's a human body. Man-made control system. Example is braking system. Combinational control system means natural and man-made control system. Time variant and invariant control system. Time variant control system means time varying control system order in which parameter of the system are varying with time. It is not dependent on whether input and output are function of time. Time invariant system of the parameter are independent of time, which are not varying with time and are constant. Next, linear and nonlinear control system. Linear control system, the principle of superposition theorem is applicable to the system. This means the response of several inputs can be obtained by considering one input at a time. Nonlinear control system, it does not satisfy the superposition. Next, SISO is a single input and single output. The system having only one input and one output is called as a single input and single output. Multiple input and multiple output. Some systems have multiple type of input and multiple type of output. These are the classification of control system. Next, types of control system. First one is open loop control system. Another one is closed loop control system. Open loop control system, a system in which output is dependent on input, but controlling action or input is totally independent of the output or change in output of the system is called as the open loop system. In open loop system, in the block diagram, the input is the required process input and controller output they send to the process and the process output. Next one is open loop system advantages and disadvantages. Such systems are simple in construction. Systems are easy for maintaining point of view and disadvantages for such systems give inaccurate results if there is variation in external environment. It cannot seem the change. Closed loop system. A system in which the controlling action or input is depend on the output or change in output is called as the closed loop system. Control system in which the output has the effective upon the input quantity in order to maintain the desired output value are called closed loop system. In the block diagram, a reference input or set input they send to the amplifier and they send to the controller and process and they send to the feedback to the input. Reference input they represent R of t and the control signal they represent P of t. Controlled output they represent the C of t. Practical example of the closed loop system. Difference between open loop and closed loop control system. In open loop control system, Controlled action is free from the output. In closed loop system, the output is mainly dependent on the controlled act of the system. In open loop system, not feedback control system. In closed loop system, feedback controlled system. The construction of the open loop system is very simple. The construction of the closed loop system is complex. The consistency is non-reliable. The consistency is reliable. So these are the mainly outline of closed loop and open loop system. Next one, feed forward and feedback control theory. This is the practical example of feedback control. Feed forward controller. Control element respond to change in command or measured disturbance in a predefined way. In both control techniques is used to compensate the disturbance. Both feedback and feed-forward control theory are used to control the techniques for the compensate for the disturbance. In the block diagram of feed-forward control, reference input, feed-forward controller, plant and output. Implementation of feed-forward controller desired in the block diagram, desired in output, inverse model of the system, input needed from the output and the plant. Ideally consists of exist inverse model of the plant can compensate for known plant dynamics delays before you get the errors. In feed forward control system, the main objective is to error self nulling. It compensates any disturbance which affecting controlled variable. It does not include feed forward feedback control system. Limitation of feed-forward, effect of disturbance or command input but must be predictable, may not generalize to other conditions, will not be occur if the system changes. Feedback control system. Plant system to be controlled. Reference input is the desired input and the output is the controlled output. Error is the error signal. Controller, feedback controller compute compensatory command to the plant based on the error. Feature of the feedback controller automatically compensate for disturbance, automatically follow changes in desired state, can improve undesirable properties of the system. Plant can be very simple. Combination of feedback and feed forward. Feed forward component provide wrapped response. Feedback component fill in the rest of the response accurately, compensating for errors in the model. Thank you.